Good evening, geometry students, and welcome to another lesson in Chapter 9. We are in Section 9-6, and this is going to be the last section for this chapter. So in this section, we're talking about dilations. And what I'd like for you to be able to do is to find a scale factor of dilated shapes and then be able to apply scale factors in order to dilate shapes. So let's talk about what a dilation is first. A dilation is when you change the size of a shape proportionally. So there's that word proportion again. This is going to preserve all the angle measures. So all corresponding angle measures remain the same. All right. So dilation changed the size of a shape into a similar shape. So all of its angles are going to be the same. It's just the sides are going to be longer or shorter. Now, a scale factor is the number that is used by multiplication. That's important. To increase or decrease the size of a shape. So we can make a shape get large or we can make a shape get smaller based off of what our scale factor is. Now, if we're going to make that shape get larger, it's going to be called an enlargement. So when the shape gets larger, or when the shape increases in size. And you know it's going to do this when the scale factor is bigger than 1. So I'm going to write scale factor greater than 1. Okay, now when we have a reduction, that means that the shape is going to end up getting smaller. In other words, the shape decreases in size. So in that situation, the scale factor is going to be less than 1. Alrighty. So when we have dilations in the coordinate plane, we're always going to dilate them around the origin because that's just going to make life a lot easier for us. So essentially what you're going to do, you're going to take your scale factor and multiply it by whatever the coordinates are. So basically, take your scale factor and multiply it to your coordinates. And you're going to see that in example here in a moment. But if you have a scale factor of 3, you're going to take each of your coordinates, the x and the y, and just multiply it by 3. And then I have a couple reminders here at the bottom of this page just because I want you to be able to know which way is going which. If your scale factor is bigger than 1, then it gets bigger. If your scale factor is smaller than 1, then it gets smaller. In other words, shape grows or the shape shrinks. All right, let's do some examples with that now. So in example 1, it says, apply the dilation D to the polygon with the given vertices. Describe the dilation. So here, we are going to take x and multiply it by 3. And we're going to take y and multiply it by 3 as well. So first what I want to do is just draw or indicate where triangle ABC is. So A is at 1, 1, and I'll label that. B is at 3, 1, and C is at 3, 2. Okay, now I'm going to connect those. This is my image, or my pre-image, I should say, sorry. Now I'm going to take each of these coordinates and multiply it by 3. So for example, to figure out what A prime is, I'm going to take 1 times 3 and then 1 times 3 again, which is going to be 3, 3, which is equal to A prime. Now B is at 3, 1, but I'm multiplying both of those by 3. So this is going to be 3 times 3 and 1 times 3, which is going to be 9, 3, which is B prime now. And now to figure out what C is, C currently is at 3, 2, but if I want to increase it by a scale factor of 3, I just multiply both the X and Y by that. So it's going to be 3 times 3 and 2 times 3, getting me 9, 6, which is C prime. So now we want to graph these new parts. So A prime is at 3, 3, so over 3, 1, 2, 3, up 3. So this is where A prime is going. B prime is at 9, 3. And C prime is at 9, 6. If we connect our vertices one more time, this larger image is our final result, and I'll shade it in. So the shaded one is the image. Okay, so then it says, describe the dilation. So this was an enlargement. By 3. And there we have it. Let's try another one. In this next example, we're dilating XY, but now we're multiplying it by 1/2. Notice how the 1/2 is less than 1, so that means this is going to be a reduction. First, what we want to do is plot A, B, and C. So A is at 4, 10. B is at 8, 8. And C is at 6, 7. Okay. I'm going to connect all those. Now what I want to do is multiply each of these terms by 1/2. So I'll just do A first. I'm going to take 4 times 1/2 and 10 times 1/2, and that is going to get me 2, 5. So this is now my new A prime. B is currently at 8, 8. So I'm going to take that and multiply 8, 8 by 1/2. So 8 times 1/2 and 8 times 1/2 is going to equal 4, 4, or B prime. Now let's figure out what C is. I'm going to take these coordinates, 6 and 7, and multiply them by 1/2, because that's the scale factor I was shown in my dilation rule. So I'm going to take 6 times 1/2 and 7 times 1/2, and that is going to get me 3, 3.5, and that is C prime. So what we want to do now is just plot our A prime, B prime, C prime to get our new coordinates. So 2, 5, I'm going to go over 2, up 5, and that is my A prime. B is now at 4, 4, so over 4, up 4. That's B prime. And C prime is over 3, up 3.5. 1, 2, 3.5. Okay. Connect them. And there's your new triangle. So once again, this guy that's shaded in is my image, while the non-shaded is the pre-image. So pre-image to image. Now we do want to describe what went on here. This was a reduction by a scale factor of 1/2, or reduced by 1/2. Alrighty, so that's how you're going to apply a scale factor. Just literally take your coordinates and multiply them what your scale factor is. That will only work if we're doing a dilation around the origin, but we're always going to do that in this class, so that's why we're able to apply that rule. Now, what would happen if we wanted to do this the other way? So it says below we are working the problems backwards. So now you have to divide your numbers to find the scale factor. So it says identify the scale factor for the dilation. Here's what we're going to do with these. To figure out a scale factor, you're going to put new values over old values, basically, in a nutshell, okay? Or the prime over the not prime. It doesn't matter which one you choose, because remember, when we have a scale factor, the scale factor is used consistently through the whole problem. So I'm going to write that down. When we use a scale factor, it is used for the whole problem. It stays consistent. So that's valuable for us because we do not have to keep doing the same problem over and over and over again. If we can find the scale factor, let's say between A and A prime, then we also know the scale factor between B and B prime and C prime. They're all going to have the same scale factor because it's all one problem. So what you're going to want to do is put your prime number over your old number, basically, or image over pre-image. That's what we're going to do. So let's just do B just so you can see this. Okay, so I'm going to put the image or the prime number on the top of my fraction. So where is B prime at? B prime is at 1, 2, 3, 4, 1, 2, 3, 4. So B prime over B is going to be 4, 4 over, okay, and now where is B at? B is at 2, 2. So we've got x over x and y over y. What does 4 over 2 reduce to? This is reducing to 2. So 4 over 2 reduces to 2. And that means our scale factor equals 2. And that makes sense because the first image was small, or the pre-image was small, and then the image was bigger. So that means that makes sense because 2 is larger than 1. So we have a scale factor of 2. It was an enlargement. Let's do that again over here. We're going to do prime over old, or image over pre-image. So choose a coordinate, but make sure that you're making them line up. So D prime has to go with D, F has to go with F prime, E has to go with E prime. Okay, so choose one that you like. It really doesn't matter. I'm going to do F and F prime. So I'm going to say F prime over F is equal to -1, 0 over 3, 0. So I've got my x's with my x's and my y's over my y's. I'm not going to worry about the y's because that's 0 over 0, and so that's funky. But I do have this -1 over 3 right here. So I'm going to be able to say, oh, okay, -1 over 3 is equal to the scale factor. So yes, you are allowed to have negative scale factors, and all that's really meaning is that you're going to change what quadrant it's in. So all we did, one more time, was take our coordinates from a prime and then put it over the pre-image value. We could have done this with D and D prime or E and E prime, and we would have still gotten a scale factor of -1/3. We'll be practicing with this in class tomorrow. So until then, I hope you have a great night and hope to see you soon.